Welcome to this session. In the last session, we were discussing about object oriented analysis and design. We said that the object oriented analysis and design actually consists of two parts: object oriented analysis and subsequently the object oriented design. The object oriented analysis part is more of elaboration of the problem statement, and the design part is design of the solution or the model of the solution. In the analysis part, we said that based on the initial use case diagram, use case construction is also analysis part, where we elaborate the problem description in text format and also construct the graphical use case format. And possibly the most important thing in the analysis part is the domain model. We were discussing how to construct the domain model for any given problem. The domain model consists of the conceptual classes, concept level classes. We just identify the names of the classes, that is what we call as conceptual classes, and the relations among the classes. This is a very important skill for any designer to come up with the design model, and we had said that we need to look for three types of objects in the problem description. One is the boundary objects, the second is the controller objects, and the third are the entity objects. And we are just discussing what are these objects and how to identify. Let us proceed from that point onwards. Domain modeling is an important part of the analysis process. Here we identify and represent the concepts that appear in the problem domain, and also we identify the relations. Three types of objects are identified: the boundary objects, entity objects, and controller objects. These three types of objects have different ways of identifying them. The boundary and controller objects are rather straightforward to identify for a problem description. The entity objects are the one which require skill and experience. With experience, if you solve a dozen problems, you effortlessly can identify the entity objects from the problem description. But initially, we need to do the noun analysis to get a hang of the things that we are looking for in the problem description. The boundary objects and the controller objects, these are easily identifiable from the use case diagram. The boundary objects are the interface between the actors and the use cases, and the controller objects have the business logic for a use case. The boundary objects correspond to screens, menus, forms, etc. And here, as a good principle, design principle, we should not have any processing embedded in the boundary objects other than getting the input and passing it to the controller object, and similarly getting the output data from the controller object and properly formatting and passing on to the actor, displaying or communicating to the actor. Other than that, the boundary objects should not have any processing activities associated with them. The entity objects, these are the crucial part of any domain modeling. the entity objects hold information for long time, like once a book is created, it remains for quite some time until the book is damaged, destroyed and written off. Similarly, the book register, one thing to note is that these entity objects kind of store data and on query return data and support things like searching, sorting, etc. But the main purpose is to store data. For example, in a library, large number of books exist and the books are the entity objects. Each book object stores some data and the collection of all book objects stores the information regarding all the books in the library. To identify the entity objects, initially we will do noun analysis. We will look at the problem description, identify the nouns in the problem description, eliminate some of these and we will have the entity objects remaining. We will just illustrate that with an example. But after we solve couple of problems, we do not have to do a formal noun analysis. By reading the problem description, it should become clear to us which are the entity objects. The controller objects are possibly the most intelligent of the objects. The boundary does not do any processing. The entity objects do only some very elementary processing. Then where does most of the logic implemented? The answer is the controller object. Each use case is implemented by a controller object, or each use case is realized by a controller object. What we mean by that is, as soon as a user starts executing a use case like a renew book or issue book, the boundary object gets the user data, what the user really wants, that is the work of the boundary object, and reports to the controller object. The controller object knows, it is the intelligent object, it knows what all steps need to be done in the issue book or a renew book, and then it initiates by requesting the appropriate objects. In this simple example, we have just it requests one of these and then they in turn take help of other objects and return the data, but in a more complex use case, the controller might request dozens of other objects at appropriate times to get the behavior required for a use case implemented. We can say that the controller object coordinates the activities of a set of objects. For every use case, it has the required business logic or what needs to be done for a use case execution is embodied in the controller object. If the use case has very complex behavior requiring interactions with several dozens of objects, the controller object can become complex. And to handle this situation, we might have to split a controller object into multiple objects. In this case, the use case will have multiple controllers, but as a rule, we will start with one controller per use case, and later during refinement of the design, we might split some of the controllers. the controllers have the responsibility of coordinating, sequencing and controlling other objects, and the name possibly started with the Smalltalk MVC mechanism. And we were discussing about the controller taking the help of other objects, entity objects, to realize a use case. The boundary, it interacts with the boundary to get the input and display the output, but it coordinates or requests several entity objects to get the behavior done, and of course, the controller does some bit of processing. Now, during the domain analysis, we have to look for three types of objects: the boundary objects, controller objects and the entity objects. The boundary objects, we need to identify or we need to construct one boundary object for every actor use case pair. One controller object for one use case. For every use case, we will have one controller, and for every actor use case pair, we will have one boundary object. And therefore, construction of these two types of objects is almost straightforward. Just by inspecting the use case diagram, we can identify how many boundary objects and how many controller objects will be needed in the initial solution. But possibly the most crucial part is the entity class requires some experience and expertise. By reading the problem description, that is the SRS document, and consulting the use case diagram, we should be able to identify the entity classes with some experience. We will just try to solve couple of problems to identify the entity classes, and we will have several problems displayed here and request you to solve those to get the required expertise to identify the entity classes. And the quality of the solution is determined by how well are the entity classes identified and represented. These two, of course, all designers can easily do, the boundary classes and the controller classes. The boundary objects, straightforward, just look at the use case diagram, and for every actor use case pair, we need one boundary. It has one boundary and we need one boundary object. Similarly, for this example, there are 4 actors and 3 use cases, but there are 4 actor use case pairs, and therefore, we need 4 boundary objects for this problem. I am sure that given a use case diagram, everybody will find it very easy to identify the boundary objects, and later in the design process, these boundary objects will become user interface components, menus, check boxes, text boxes and so on. The controller object identification is also straightforward. Look at the use case diagram, and for each use case we need one controller, and in this simple example we need exactly one controller classes, and we will name it as the play move controller. For this example, we need 3 controller classes: the register customer controller, register sales controller and select winner controller. Now, let us try to identify the entity objects. This is the most crucial part of the design process. We must understand that the entity objects typically appear as nouns in the problem description. Some of the nouns in the problem descriptions are the entity objects. but then not all nouns in the problem description are entity objects. We need to eliminate, once we underline the nouns, we need to eliminate most of this. If it is the noun corresponds to a user such as accountant, librarian, etc., we will eliminate it, because these are actors rather than entity classes. Some nouns are actually passive verbs, they are verbs, but then in the text they are written like a noun. For example, acknowledgement. Acknowledge is the verb and acknowledgement is the noun form of this verb. And these also are not entity classes, these are basically verbs, acknowledgement, etc. These are verb forms, even though they appear as noun, these are verbs. And later we will say that see, the nouns, if they correspond to the entity objects, the verbs correspond to methods. Let me just repeat that. The nouns correspond to entity objects, some of the nouns, and the verbs in the problem description, they correspond to the methods. But the question remains is that which class will have which method, and that we said that the interaction diagrams will help us to identify which verb or which method belongs to which class. So, the passive verbs we need to eliminate from the identified nouns, and we will also examine the nouns that we identified and find out with which we cannot identify any data to store, because after all the entity objects need to store data, that is the basic definition of entity objects. If we cannot think of any data that this entity object will store, then we need to eliminate it. It is possibly an attribute of another class. We will discuss some examples there, we will again remark this. And those nouns with which we cannot identify any method at all, for example, store, get, etc., such methods we should be able to identify with the entity objects. If we cannot even identify any methods which will be associated, store, get, etc., then these are not entity objects. The examples that we discuss, we will see that we eliminate the identified nouns based on these criteria. But of course, we should be careful that sometimes we actually have entity objects which appear as users. Even though the library member is a user, but then we need to have an entity object as a library member, because it will store the member details, the books outstanding, and so on. Many times we will have the users appearing as entity objects, but not always. Whenever there is a user, in the noun form a user is present, we need to check whether we need to store such the information associated with the user. For library member, yes, because we need to find out who are the library members, what are the books outstanding, and so on. And we call this as the surrogate users. We will see that the entity objects typically occur in groups. For example, book, there are thousands of books, they occur in a group. Let us say library member, there are several library members and they occur in group. So, this is possibly a hint that if there are several objects of the same type, then it is possibly a entity object. but even though these represent a large number of objects, for example, the book class represents, from there we instantiate thousands of books, but please remember that the name of the class will be in singular. We should not have a class called as books. The class name is book. The class name can be student. Students is not proper. The class name students in plural is not proper. Please try to give singular name to the identified entity classes, even though they represent large number of objects. Now, let us look at one simple problem description and let us perform noun analysis. A trading house, so this is part of a problem description. We can do for the full problem description, but let us just do for the part now. A trading house maintains names and addresses of its regular customers. Each customer is assigned a unique customer identification number or CIN. As per current practice, when a customer places order, the accounts department first checks the credit worthiness of the customer. Now, let us do the noun analysis. Let us identify all the nouns. Trading house is a noun, we will underline that. Name is a noun, address is a noun, regular customer is a noun, trading house is a noun, name is a noun, address is a noun, regular customer is a noun, customer is a noun, customer identification number is also a noun, practice is a noun, order is a noun, accounts department is a noun, credit worthiness is a noun, and customer is a noun. The first thing we should possibly do is eliminate these duplicate ones. The customer is present here and also customer is present here. We should take one of that and let us apply the criteria that we are discussing, that the trading house is the name of the organization, and in the software we do not have to really store data about the trading house. We cannot really associate any methods with a trading house. For example, store, what do we store about a trading house, gate and so on. So, we will eliminate it. What about name and address? The name and address also we cannot associate any method. These are attributes actually of the regular customer. We do not change the name of a customer normally, and we do not separately store names and addresses. So, we will eliminate that. Regular customer, okay, yes, we need to store data about customer, but then the regular customer and customer, they are synonyms. So, we will eliminate regular customer and we will just have the customer. The customer identification number, similarly, we cannot store data about customer identification number. There is just one data item and it is an attribute of the customer rather than an entity by itself. It is just one data item, and typically an entity stores multiple data items, and we cannot really associate any meaningful methods with the customer identification number. It should be an attribute of the customer. Similarly, practice is the noun form of a verb we should eliminate it. Order, okay, yes, it is a noun, we can associate data and methods with the noun, and therefore, we should have this as a entity object. Accounts department, we do not need to really store data about accounts department, we will eliminate that. Credit worthiness is also not data to be stored, it is not an entity object, and customer is a duplicate. Here we have appearing customer 2 times, we will eliminate one of that. So, that leaves us customer and order are the 2 meaningful entity objects. Based on the noun analysis here, we could identify the nouns, eliminate the ones which are not entity objects, and got 2 entity objects from this problem description. You can read through the entire problem description and identify the entity objects, but then after practice and problem solving for couple of problems, you will see that just by reading here, you can make out that customer and the order are the only entity objects in this text description. But we should be, there are some helpful hints we can mention in identification of the entity objects. One is that if we know procedural design, then in the data flow diagram, the data stores typically are the entities. If we look at the DFT model, the data stores correspond to entity objects, and the entity objects almost always occur in groups of large number of objects, and these are aggregated like a book register aggregates large number of books, and typically we use something like register or something, member register to aggregate the members, book register to aggregate the books, and therefore, those are also entity objects. We identify the books, there is a large number of them, and book is an entity object, and also a book register is an entity object. We are almost at the end of this session. We will stop here and continue in the next session. Thank you.